we have this wonderful chance to look at what can be done today. And with our peer Paolo and our colleagues from Milan, we will start the presentation now. I would like to introduce our two colleagues, Mr. Giulio Valeri and Paolo Giancane, who will make a presentation on the World Food Security E-Center, which is not just World Food Security, but it can be much more than that. Mr. Valeri, you have the floor.
Thank you very much to Sir Giancane for his deep and motivated presentation. Thank you. Good afternoon. My name is Giulio Valeri, CEO of Software Solutions Milano, Italy, and ECT advisor of OCCAM. It is my first time in the United Nations, and I would like to thank OCCAM President Paolo Saporito for giving me this beautiful opportunity. Together, my colleague Paolo Giancane, board member of finance director at Vesenda, producer of a platform eLegere, will present you the project Food and Health Security Center developed by OCCAM. The core of this project is to use innovative services and technology to support countries to develop adequate, rapid, and efficient food security and safety policies. This diagram summarizes how this multi-level support was achieved. In the center, there is the village, and the support network has been developed around. The first level is the district in the village, the second level, the local institution in the country, and the third level, the service providers, center of excellence, located in different countries in the world. These are only some fields of application for which the platform was created to manage the development and solve problems of agriculture, animals, food, water, plants, irrigation, telemedicine, and human nutrition. Service users of developing countries will be able to benefit from the skills achieved by the service providers in order to transfer knowledge, solutions, and enable faster skill development. Internet of Things, IoT, wearable technologies, and mobile devices are the new frontier of digital solutions and are widely so used by the World Food and Health Security Center platform. The information collected integrates advanced data processing such as big data, artificial intelligence, predictive analytics, and smart contracts like Bitcoin, blockchain. The Infopoverty Hub connects users with mobile devices, automated robotic systems and sensors to the network of specialized laboratories and centers of excellence. The Italian Association of Agricultural Science Societies, AISA, supports the OCCAM project with all its expertise in different fields. As you can see, they can give help with all their experience. Now I turn to Vesenda and Paolo, who is going to briefly provide you with an example of a workflow of an end user requested to district national centers and service providers to solve a problem.
Thank you, Giulio. Thank you, President Saporito, and thanks to all of you. I'll be happy to explain how the software at the center of the hub works. I'm not a technical person, so I'm not going to be into too many details. I will be using layman's words. My goal is to provide an example of how the workflow of information is actually transferred across the different users and then to the service providers. So as Giulio mentioned, we got different players, and we'll see how the request starts with the end user. So, for example, it could be a farmer, or any person habilitated by the system to work through the channel of information. So, for example, the end user inserts request information through the mobile application, takes a picture or whatever he thinks is important to be transferred across the system, and submit the request. So that's the role of the end user. The end user, we can think of a farmer in respect to an agricultural problem, or a doctor on the grounds needing to inform the rest of the players in the system across the workflow management of data. So the end user will shoot a picture, so take a picture and send to the district within any geographical localization. The district service validates the request, could validate the request and insert further information. For example, notes or attachments. Provides initial feedback, and if at the district level the problem can be solved there, then a solution is being sent back to the end user. Otherwise, the district organization can share the information received from the end user plus any additional documentation to the national center. So what I want to highlight here, that the information are actually transferred or shared across the channel, not through email system. So all information are actually available through the workflow management, through the technology that we have made or we will be made available for this process without any sort of email or transfer. So they are automatically through the system available or mobile, basically, on the cloud. And whoever is in charge of the whole process can decide the level of integration, can decide the level of engagement by the different players. So it's very important to highlight that the organizational level, in terms of corporate governance, there is total centralization of information and total control from the authority, the local authority in charge of the process. The national center, so the national center analyzes the request topic, monitors the environment, can basically assess the information in conjunction with other potential requests. So if the request comes from a doctor in a specific hospital, can analyze the information in the context of other similar or different inputs. Validate the request again, and it may add additional information to the process. Provides additional feedback, and then submit the request to the service provider. The service providers may be local organizations like hospitals, national centers for agriculture, which are basically those solving a problem when deemed so by the national center. So the role of the service provider. The service provider eventually analyzes the problem as received, provides diagnosis feedback, sends an initial solution to the national centers, and then the district centers share results, and all the information and the data, the knowledge accumulated through the process basically will or can be connected to any intelligence service such as artificial intelligence or machine learning. So all the information basically circulating through the system will be the base for new knowledge. So this system is not intended to be artificial intelligence, but can be easily connected to any application enriching information and knowledge. And now, please, Julius, we will launch a video where basically the process that I described earlier is shown to you. So the user identifies itself, add a request, specify the kind of information or the problem he believes is facing, and eventually he will take a picture. We'll take a picture, we'll record the message. So the system is intended to be, in this case you will see he's taking a picture of a plant which is attacked by a war. See, a picture is taken, then transmitted to the Infopoverty hub in real time. in this specific example, we have a kind of mock experience through a video, voice recognition. The way information is shared across the hub is multiple. So that's the way we think the knowledge can be shared across the system. Now I will turn to the video from the perspective of those receivers of the information and the district, national centers, service providers who manage the information, enrich the information, and bring back the information in the system to create learning. So the first video we saw from the perspective of the end user, see now from the perspective of the different steps, district, national, and service provider. In this specific case, the district center receives the picture, makes a decision in respect to the importance of the picture, and then if the issue is deemed important, is sent across. Rather than sent across, is shared, because there is no actual transfer of knowledge, but it's a share of knowledge. The system also allows to geolocalize all the requests. To open the request, to check the nature of the problem, and then passing to the national center for future decision making. Okay. So the national center receives a notification in respect to the problem, receive the request from the end user through the different district and centers, and this request is basically classified by type, theme, subject, period, location, districts, the way the national center deems appropriate. So what I want to emphasize is what you see there is an example of how we might organize the management of information, but it's going to be the local institution with knowledge of the grounds to decide how the information or the problem is actually classified. So the service provider, we eventually will share all this information through the platform to enrich the platform through intelligence services, again, like machine learning. And I don't know if you want to use the example of the Magnolia, because it's an example, but actually can be easily referred as a practical issue faced by...
It's true. The choice of a magnolia is not accidental. In Africa, because of a parasite, a large amount of magnolias have become ill, and no pesticide could stop the epidemic. And every time the parasites become stronger and more voracious. Several specialists in the world were then asked, and one of these, after careful analysis, identified that the parasite that ate only the leaves of magnolia came from South America, probably present in some not disinfested plants from those countries, where, however, it had an antagonist, a bee, that only its larvae. So these bees were imported, reproduced in large numbers, packed in bags, and threw by airplanes in the territory where there were the magnolias. In this way, the epidemic has been stopped. This confirms that the sharing of knowledge through the current ease of communication can make it possible to quickly and effectively solve problems all over the world. And I have to add, without pesticide. In this way, we have found a natural way to kill a parasite. The colleague of Accra, who has followed the story in the first person, can give you more details. The colleague has told about this story some time ago. Okay?
And so we're getting close to the end. I just want to summarize a few key features of the Infopoverty Hub. So why is this application different than other you may have heard of? First of all, we're not going to replace the idea of the whole hub is to bring different tools together. So it's not machine learning, but it can be easily connected to machine learning. So the idea of the hub is about technology which can get different tools working together towards the satisfaction of needs of those less fortunate than us. So in particular, the possibility to use any system. We're talking about desktop, tablet, and mobile, web with smart data input. So the data can be inserted along with images, text, voice recognition with geolocalization, which is very important, especially with large regions. Users can be easily profiled with secure access. So it can be easily centralized and decentralized and easily identified who is and how the information is actually entered and managed along with data history tracking. We have the platform envisage a web database to store any sort of information and georeference data entry with geovisual data navigation. Data collection is centralized, meaning the local governments or the central government has all the time control of the information and can decide how the flow of information is shared and transferred across the chain. Interoperability with external tools. So if the organization, the constituency, decides to move forward and implement the Infopoverty Hub, whatever investment in IT is already in place doesn't necessarily have to be replaced. So can be easily connected to the hub. So this is a connector of tools. And interoperability with Internet of Things and intelligence services. So that's the beauty of the solution for which we show a video in respect to agriculture and food, but can be easily transferred to health issues and linked and benefit from existing technology on the ground.
In this summary slide, I represented the SAM project realized by OCCAM. Dagara in Ethiopia, Villa El Salvador in Peru, San Salvador Norte in República Dominicana, Sambaina in Madagascar, Navajo Organ Center, Mahobong Lesotho, Meis El Jabal in South Lebanon, Sam Rabon in Honduras, Borgi et Tuile, Tunisia, and Yarapa in Ghana. These are all things realized. So OCCAM is a constructor of these things. It's not only talking about this opportunity, they realize these opportunities. Here is the summary of this proposal. And we have to say that somebody asked to us how much it costs, this sort of application and this sort of proposal. And what I want to say today is that it costs $1. $1 for each person in the country in which it will be implemented. This is a consideration we have done with OCCAM President, Paolo, and we try to finalize our proposal, our projects in this way. Thank you very much for your patience and for your interest. And we are here for any other sort of explanation about this application. And here we have the phone where we have realized the app that is ready and it's possible to use it to see how it works.
Thank you very much for this very, very interesting presentation. I think what attracted me to this initiative and this platform is the interoperability despite the centralized data collection system, and scalability, which means that it can be integrated and scaled up into the existing technologies and platforms that may be operating in any country, and that it can go beyond the area of agriculture and food into health and other areas as well. And also, interestingly, it also has key features which are very future-oriented, which means that we are talking about the future digital age, artificial intelligence, blockchain, big data, all the key features which are driving the second generation internet revolution are already built into this platform, which is very, very important because initiatives come and go, platforms are built and then they are lost. But if you have those kinds of features in a platform and in an initiative, then it is likely to survive.